We're gonna get going here. My name is Ken Easterday. I'm the product manager for fixed instruments here with Bacharach. Rudy had asked me to get a meeting online and walk through the basic configuration and commissioning of the MVR system, which will include the MVR-300 and the MVR-SC, which is the controller. And we'll go through all the network configurations and things like that. So I'm assuming that everybody is at least familiar with the products. I'm going to go over some highlights. The thing that I wanted to cover first was the MVR-300, and this is the actual gas detector. This is the gas detector that's going to be in the rooms, in the occupied spaces. It will detect the gas. It's got a Modbus interface. It's got a power, input power, 120 volts input. And then it's got 2 alarm relays that can also be used. One of the things that I want to address right up front, and in fact, we want to highlight here that we do suggest that these can be put in a 2-gang or a 3-gang box, electrical box. We are going to restate that language from here forward and say it's going to be a 3-gang box. Now, these things can go in a 2-gang box, but it's really tight, and it's just an easier install for everybody if it's a 3-gang box. So I want to put that on the table right now. We will be going back and changing all of our documentation here in the very near future to address the 3-gang only. Couple of the other things with the MVR. If I could, I'm assuming that everybody can see my screen here. I'm going to be referring to my screen here occasionally. Typical layout in some sort of occupied space, and this is what I'm highlighting here. This diagram is a typical hotel room, which is a big application, but rehab facility, hospital, whatever, the details are the same. And what we're doing here is we're choosing locations where the appropriate places for an MVR-300. And really, it's right around that VRF system that's inside the room. The refrigerants that you use in VRF systems are heavier than air. They're going to migrate to the floor, and they're going to concentrate on the floor. We talked about this earlier in the call before we got going officially. Typically, our range is somewhere from 6 to 18 inches off the floor. 12 inches is a real good spot. You could even go a little bit lower with that, but 12 inches is probably going to work. Now, you want to put the gas detector near the source and preferably in the ambient airflow. And if you're seeing my screen, the air conditioner ambient airflow is going to be across the bed and out the door, or there's going to be some sort of cold air return near the door. So this ambient air is typically going to flow towards the door or towards airflow. So good place for the gas detectors are right near the VRF systems. Couple other things with the MVR. There are some dip switches on the back for configuration, and it's all about the relay settings, whether they're fail-safe or not, whether there's a delay or not, and whether or not they're latching. So the relays can be configured through the dip switches. And then the connections to the MVR-300, on one end, you're going to have both the Modbus and the power. And then on the other end, and then on one of the sides, you're going to have a high gas alarm and a low gas alarm. You have to have the 120 volts coming into it, and you have to have a Modbus input since you're going to be configuring to the controller. I'm not sure if there's going to be auxiliary systems for the alarms, but these are typically connected to auxiliary ventilation. If the gas detector detects a low alarm or a high alarm, sometimes these relays can be used to turn on added ventilation, or they can be used to, go ahead.
Yeah, Ken, so sorry to interrupt you, but the low gas alarm and high gas alarm, our thoughts were to take that low gas alarm, because from my standpoint, if there is any kind of alarm that goes off because of refrigerant gas, we want to know about it, and we were going to tie that into our nurse call system.
Okay.
Our patient stations, which are located right by the bed there, can actually take inputs from other devices. And so our thought was, if we can take a normally open input, it closes during the gas alarm, to that patient station, it's just a close contact, and then that would set an alarm into our nurse call system and alarm the nurses right away that, hey, you got to go to room 175.
Okay, and they're going to then have the protocol to react to that.
Correct.
Okay, very good. And that's typically what can happen. Now, as we get into, Mike, as we get into the controller, you'll see that there is also a higher level alarm contact that you may be able to use as well. Maybe it goes to a fire panel or something. So
sure. So I like that, but the controller itself, are all these devices addressable? In other words, will the controller know which room the alarm went off in?
Absolutely.
Okay, so really I don't need to then. I probably don't need to tie to my patient station. I can tie to the controller. I can tie my nurse call right to the controller.
How? Well, okay. So the way these work is the controller is connected to each one of the MVR-300s through Modbus and through the network that we're going to go through. So that connection's already done. Your low alarm and your high alarm can be used for other things.
Okay. So yeah, it makes sense to me actually. The more I think about it, if we do that exact, because we're talking from where you're locating, and we're talking 6 foot of probably 20 gauge two conductor coming out of that MVR-300 to our patient station, and now we have an alarm right at the nurse's station.
Sure. No, I think that's a reasonable solution.
Okay, and then put the controllers in a mechanical room nearby.
Okay. Yeah. I think that's the way to do it. But I mean, there is a little bit more flexibility there, but I think your logic is solid.
Okay. Do you have wiring diagrams at all that show? I mean, obviously with the relay contacts, I'm just taking a 22 conductor. With the Modbus, is that a Cat 5 or is that like a twisted shielded pair? Or?
Modbus is typically a twisted pair with a shield and ground, and we can get to that in a little bit. We'll go through all that stuff when we get into the controller stuff.
Okay, perfect.
Yeah. So these are your basic connections for the MVR-300. And then it's just, configuring the controller. Now, there's a lot of other direction on our quick start guide, and this is all about how the LED operates as it responds to an alarm or a fault. It's all about how the calibration modes respond and kind of understanding the LEDs and the frequency of lighting. So that's what this is all about. And then, you know, some of the use with the magnetic wand. Now, you're going to find, though, when you get to the controller and you're going through, it's a little bit easier to use than what this table may seem like. So let's move over to the controller, and then we can maybe fill in some more gaps that are creeping into your mind. The MVR-SC is our controller for our VRF gas detection systems. And the controller, you get central alarming. You can connect up to 100 of these MVR-300 gas detectors in our hybrid network. And that network is going to consist of some Ethernet and some Modbus. And we'll get into the details around that in a couple slides here. It's a touch screen LCD. It's really intuitive, it's really simple, and it's really not complex. If your screen looks like the picture in my slide, everything's great. If it looks something other than what's in my slide, you got to do something. It's really that easy to understand. And again, there are alarm and fault relays inside the panel for interfacing with a building automation system or some higher level alarming. These are the basic pieces. You've got the controller, which is going to be all the centralized alarming and configuration. You've got an Ethernet switch. We sell an Ethernet switch, or you can buy an Ethernet switch off the shelf. It's just an Ethernet switch. These gateways are kind of important, and this is our Ethernet to 485 converter. So we're taking Ethernet signals and getting them to a Modbus RS485 network, and then that's going to connect into the MVR-300. So these are the basic pieces of the entire network. Obviously, the MVR-300 is in your occupied space or your room, and these other pieces can be remote from that, however you want to lay it out. But this is essentially what the network looks like. So you've got the controller. You're going through an Ethernet switch. That Ethernet switch can be 4-port, 8-port, however you scale it, but there is a limit to the controller of 100 connected gas detectors.
So how many can we get on a gateway?
Up to 15. So you're going to be sizing your network through the gateway, and then there are up to 15 of these MVR-300s on each one of the gateways. Okay. And these are going to add up to 100 as you go along that 8-port Ethernet switch. The scan time is typically about 15 seconds, depending on how many of these things are on the network. And what the controller is going to do is it's going to go out as a Modbus master, and it will go to each one of these gas detectors in sequence and pull them to see if anything has changed. If nothing has changed, that means everything's great. It moves on to the next one, and it repeats the sequence. If it detects anything along the way, it will respond as configured.
And Ken, just to give you a frame of reference, it looks like, we would need to, one thing we need to clarify is exactly how many of these are going to be necessary, but it looks like it's somewhere around 150 of them. So they would need 2 of the MVR-SCs, and then
yeah, right.
Okay.
Yeah, and actually that's there's a little bit of an advantage to that. Obviously, there's the first cost, but the advantage is you can zone and network your floors a little bit easier because you have a little bit of room. You know, for instance, if you know floor one you know has 8 rooms and floor 2 has 12 rooms, you know, you could use these gateways can span floors as long as you have the addressing correct. All of the MVRs connected to one gateway don't necessarily have to be in the same location or on the same floor. So it's a little bit flexible. Any questions about the overall configuration? We'll get to a little bit more of this.
Yeah, Ken, I've got a question. This is Mark. Have you found any type of limitation in the distance that you can run the Ethernet?
No, Ethernet, there should be almost no limitations on. Now, when you start to talk about Modbus, though, there may be some Modbus limitations, and that typically has to do with either you have a simple Modbus network where it's each one of these legs is under 1,000 feet, which I think is reasonable with only 15 gas detectors. Because if any Modbus network gets to be over 1,000 feet, then you have to start considering signal conditioning and repeaters and all that other kind of stuff to make sure that the signals don't degrade. If you keep it 1,000 feet or less, you don't have to worry about it.
I don't think we'll be anywhere close to that just because they're all patient rooms are all jammed together.
Yeah, right. That's what we find. This is an open network. Modbus RS-45 has been used for years and years and years in building automation. You know, the newer networks are things like, you know, BACnet and some of the proprietary stuff that you get from, you know, the Emersons or the Johnson Controls or people like that, you know. But no, Modbus is completely open. Tools are free to use. There's all kinds of libraries and user groups and stuff online, and you can get all the information you want. So this is the inside look at the controller. And really, the brains of the controller is really just this HMI that we have in here. It handles all of the networking and the logistics and stuff behind it. We put it inside this enclosure because we have to have some more stuff. We have to have input power, and the power to the controller is 24 volts DC. Here's your Modbus wiring inside the controller. So this is the controller is a Modbus master. But you're going to be coming out of this with an Ethernet port.
So Ken, your 24 volt DC, do you have a plug in a cord that comes in, or how do you do that?
No, that's just a 24 volt signal that is provided by the installer.
So you don't have, I mean, because we're obviously going to be plugging this thing into the wall then, or you know, bringing 120 volts and putting something to transform it down to 24 volt DC. Yeah.
You know, we've got some room here on this DIN rail that if you needed to put a 124 to 24 volt transformer in there on this DIN rail, that's perfectly acceptable. And then you just come in with your 24 volts. And you can go out through your cable glands and plug that into a wall or hardwire or whatever you need to do.
So do we know the power consumption?
Boy, I don't know that off the top of my head, but I can figure that out probably by the end of the call. If not, we can follow up with that.
Okay.
I can pull up a data sheet.
Yeah, I'm surprised that's not just built into your controller.
Yeah, yeah. I mean, this is all relatively low power. Now, the thing that I wanted to point out here is this Modbus connection here. This is actually an auxiliary Modbus connection, which is just coming off of this HMI. There's actually an Ethernet port off of here that is going to be going into that the hub, the Ethernet hub, and then to the gateway. So there's an Ethernet switch port on here that Ethernet's coming out. And then here at the top we have two auxiliary contacts, a fault relay that will change state if the controller doesn't communicate with any of the MVR-300s or can't communicate with some of them. That means there's a communication problem and it's going to throw up a fault relay. So somebody's got to go figure out what that communication issue is. So that's that fault relay. And then there's another alarm relay that will react the same way that the alarm relays will act in the MVR-300.
Okay. And then you mentioned that fault relay and the alarm relay. We will tie those into the nurse call also.
Okay.
That way they have a general, hey, we got a problem with the system, but it's not, and then the other one will tell them through the patient station exactly which one it is.
Right. Yeah. Well, and if you get an alarm here,
might not be a problem with an MVR.
Right. It may just be a communication issue with maybe the Ethernet side of it, right? So yeah, that's a higher level for sure.
Okay.
Cool. Okay, so again, getting back to the network components, in between the controller and the port and our gateway, this is all Ethernet. So it's all Cat5, simple connections. Typically these things have some sort of a wall wart power supply or something like that. But for the gateway, you'll come in with Ethernet, you'll go out RS-485 to the MVR-300. And again, the Modbus is typically 2-conductor, 3-conductor, twisted pair, 18 to 24 gauge, whatever you want to use with your Modbus cabling.
That's power too.
Yeah. Larry was just pointing out here that both this Ethernet switch and the gateway will have some sort of power need. Typically these are, plug-in wall warts that you just plug in. They're 24 volts or 12 volts or whatever the internal voltage is.
Yeah, they usually come with a power supply, correct?
Yeah, typically they will, yes.
Yeah, right.
And like I said, Ethernet switch, you go buy that off the shelf someplace. We've got some specifications around this this converter here, and we've got a little bit more detail that we'll share with you regarding the configuration. But Ethernet switch, yeah, you can go to Best Buy and get those too.
Well, we'll probably just spec that Moxa.
Right. Yeah. And we give some configuration advice around the Moxa converter as well. Okay. Now, so that's really all the hardware. Let's talk about hardware questions or gaps that I left or any other questions regarding the connecting parts.
On the MVR-300, what's the calibration? How do you do that? How often? Those sort of things.
Yeah, good question. So all of these gas detectors come pre-calibrated from the factory. So we run them through the test and we put sensor elements in and we calibrate them per serial number. So they leave the factory calibrated. Now, And as far as yearly maintenance is concerned, we sell pre-calibrated factory replacement sensors too. So the sensors are pre-calibrated. Now, you may find some AHJs, authorities having jurisdiction, that will maybe require a bump test on VRF systems. That may happen. And frankly, Bacharach recommends a bump test, a functional test after installation. So that's after everything is installed and working correctly. You go and you get some target gas and you expose each one of the gas detectors to some of that gas, and if they react correctly, everything's golden. So that's how that stuff works. Does it make sense?
Yeah. Is the calibration something that the owner can buy a kit and do, or is that has to be done by somebody specifically, or?
I don't think it needs to be done by somebody specifically, but it should be somebody that has basic knowledge of refrigerant and gas detectors and testing.
Okay.
It doesn't have to be done by factory personnel if that's what you're asking. We give instructions in our quick start guides on how to do that. It's in our user manuals how to do that, how to calibrate, how to do a zero span test, and how to do a calibration test. Yeah, you don't have to have some sort of license or law degree to do calibration.
I have a question on the detector part number. I see they're available for our 410A with different low alarm levels. What do you typically see for VRF system?
That all depends. We have 3 different part numbers for each one of the 4 refrigerants that we offer, and each one of those 3 part numbers has a different set of settings, but those are just factory defaults. Now, the thing that is important with the part numbers is the detection range, and I think it's 0 to 2500, 0 to 5000, and 0 to 10. And that all depends on the concentration of the gas being used. So sometimes there may be some background noise and things like that where you may need a higher concentration gas detector, but typically with commercial refrigerants, 410, 47, 404, R32, detection levels are somewhere around 1,000 parts per million. Sometimes that could be larger depending on the application. But I think that 0 to 2500 is a good range with alarm points, somewhere maybe around, 800 and 1500 or 1800 or, something like that. The exposure levels far exceed those set points.
Okay.
Did I answer your question?
Yes. So it sounds like we want the part number 6203-0001 then.
That could be. I don't have all the part numbers right in front of me right now. We can verify that though.
Yeah, Ken, that's the 0 to 2500 ppm.
It is? Okay.
Do they have to set the parts per million in the setup?
Well, we have factory default alarm points, but you can modify those to whatever alarm point you want. The concentration 0 to 2500 is a feature of the sensor element itself. You can set those alarm points at something other than our factory defaults. And I don't know what those factory defaults are off the top of my head right now. I got Larry looking for factory defaults.
We'll have a few of these mounted in some more humid spaces like the central bath area for the patients or laundry areas. That looks like it wouldn't be a problem. It goes up to 90% humidity. Is that true?
Yeah, it is true. Now, you need to be careful if it's really high humidity levels. These sensor elements could be affected by that, and you could get maybe some nuisance alarming. But I think that if that happens, a good calibration exercise would probably, you know, kind of put a baseline around that humidity level. But yeah, if you're putting these in high humidity areas, I would recommend that calibration be done for those particular ones, just so you can, you know, kind of zero out that humidity. Okay, I've got some info. You're using R410A?
Yes, we are.
Yeah, so your low alarm for the 2500 range is going to be 500, and your high alarm is going to be 2000. But again, those can be changed to whatever value you want, as long as you don't exceed the sensor range or go below the minimum detection level, which is, you know, in the 100s, so low 100s. So I wouldn't worry about that. Thanks, Larry.
So,
okay.
what is the benefit, Ken, of having a low alarm and a high alarm in a nursing home situation? I mean, should we not, if we have a low alarm, my guess is that we're going to tell these people, don't, you know, get the patient out of there right now.
Yeah. Well,
is the high alarm really any benefit?
You know, and this is kind of what I was talking about a little bit when we were going through the MVR 300 details. Is the low alarm may be, it may be that the concentration in the room is rising, but that low alarm relay, if the ventilation were increased, it could take that concentration back down to below alarming levels, and then you don't have to do anything. It's just a increasing the ventilation and letting somebody know, hey, you got to check on this, right? So it's not really a detriment at that point. And then typically we treat the higher alarm as there's a serious concentration here. We're going to shut down the VRF flow with that high alarm relay, and we're going to get people out and get it fixed a lot quicker. So it's more of a, we kind of use the low alarm as a notice and, hey, I need to increase ventilation, and high alarm as there's something seriously wrong here and we need something done quicker.
Well, I mean,
now,
realistically though, you have a refrigerant leak if the low alarm goes off.
You do. Yeah, you're right.
Okay. So, Terry, your opinion, I guess, would be appreciated, but my thought is we're going to take the low alarm to the nurse call, and at that point, we're going to get that patient out of that room.
So,
you know, it may not mean, you know, shut the whole system down, but we want to take the low alarm to the nurse call.
So, you know,
do you agree?
According to ASHRAE 34, the limit of exposure period is 1,000 parts per million. So, you know, the 500 level is like a warning. They could still be in there, you know, for a period of time, but they should get out. They're not going to get out of there immediately. But at the high alarm,
yeah,
get out there immediately.
Yeah, and you also have to, when you're thinking about ASHRAE and things like that, so those exposure levels, some of those may be time-weighted averages too. So typically if an occupant exposure level is 1,000 parts per million, that's over an 8-hour time-weighted period.
Yes.
So you can be exposed to 1,000 over 8 hours. Now, I'm not saying in a rehabilitation center you want to expose, fragile patients to that, but
Right.
that's kind of what the law is. But you guys are absolutely right. If you need to alarm at a lower level and you need to take different action than what we suggest, I mean that's certainly plausible. We just kind of use the standard everyday stuff.
Okay. I mean, I think because of the odds of, unless you're having a lot of alarms that go off because of calibration issues, which may be the case, I don't know. It makes sense to me to just to let the nurses know at the 500.
Yeah. 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 That seems reasonable. And again, you may, high humidity levels, you may have to do a little tuning on that.
Okay.
If these things are around, restrooms or other places like that, you can get all kinds of cross contaminants. Yeah, standard propellant. You've got propellant in medical devices. Asthma inhalers have 134A in it. And so if you do a puff on one of these things, it may expose it. So you need to be careful. I do want to get into the configuration part of it, the Modbus addressing part, because there's a couple different ways you can do that. So I just
have a quick comment. There was a couple questions on first the consumption, and I found in the specs that it's 0.44 amps at 24 volt DC.
Yeah. Thanks.
And for your electrical connection, the blanking plug's a 7/8 diameter hole.
Coming out of the bottom of the SC?
That's correct, yes.
7/8. Nice.
7/8.
Thanks, Bob.
You're welcome.
Okay. So going over the touch screen interface, again, if you see this screen on your controller, everything is golden. Couple of the icons, you press on this icon, you always get back to the home screen. If there are any alarms or faults or communication errors, these icons will typically turn color, and this entire screen will move over to either the alarm screen or the fault screen or the communication screen. This other icon here is the floor icon, and you can press this icon and then you get to your floor list, so you can look at the individual gas detectors on each one of the floors. For instance, address number 6 may be alarming, address 7 may have a fault, and address 8 may have some sort of a communication error. Modbus address 9 is good, and Modbus address number 10 hasn't been commissioned yet. So these icons will correspond over here. So again, really basic screens, really easy to use. There's not much high-level stuff here. The settings gear on the home screen, and actually I think you get this on most of the screens that you have. This will take you into the settings screen, and you get into some kind of inner workings of the controller itself. There's a service mode where it'll disable all the buzzers and stuff for 30 minutes for testing. That way you're not scaring people out of their rooms, when you're sitting there testing your system. there's an event history that just shows a rolling list of events that go on with the controller. It'll keep track of all the faults and the COM errors and things like that. There's a real-time clock in this that will need setting at commissioning, and that's how it keeps the event history. There is edit device ID. This is how you edit the individual Modbus IDs on each one of the gas detectors that are connected to it. The network configuration tool, this is where we have a CSV file that we include with the controller that you can use a spreadsheet to configure all the Modbus addresses and how your system is going to be laid out. And you do that on a computer, and then you can upload it into the controller. And then it then the controller knows the configuration of the network, and then you can use some other tools to go and commission each one of the individual gas detectors, and that's this commission tool down here. And we can work with you guys and get a little bit more detail around this, but it's really kind of easy to use. This is just a slide that just shows the different screens. Again, system normal. This is what it's going to look like if there's an alarm detected. It'll give you the ability from the controller to mute the alarm. So that will mute it in the room. You have the ability to go in and click on the details, and then it will bring up that particular room, and you can see if it's a low alarm, a high alarm, etc. Same thing happens if there's a fault detected. You'll be able to mute the alarm. You'll be able to see what the details are, and you'll be able to figure out where that MVR-300 is located. Same thing with a communication error. So all three of those system events are typically what happen, and the controller logs them and tracks them and will tell you exactly where they are. This is the floor planning spreadsheet. So there is an SD card or a USB stick or some sort of a device that has this CSV file on it. And what you're going to do is you're going to go through and fill out the floor and the room information. So all of the things in gray are already configured. And you'll see that you can get up to 15 gas detectors on each one of these gateways. Modbus ID in all the MVR-300s, the default is 1, and the controller recognizes Modbus address 1 as being the default, and the controller, when it sees that, it will want to commission that to some other Modbus ID. And it'll be 2 through 16, whatever that is. And we'll show you how to go through that. This is a typical configuration. You can see here we're on floor 6. We have rooms 602 through 605. It'll show you what zone you're in. Typically, that's what gateway you're going through, and it'll show you the address. That is repeated in the floor view, and if this has already been commissioned, it'll show you the status of what that Modbus ID is currently, or it will show you something like this, where it is suggesting that that ID has not been commissioned yet. And that will cause the system to say, hey, this is an ID1, it needs to be commissioned, let's go ahead and move through that commissioning. Now, once you have that CSV file uploaded to the controller, there are two ways to go and to commission the MVR 300s. There is a two-person technique where all of the hardware is installed. You have a controller on the wall, you have all your network connections made, you have your gateways commissioned, and you have your MVR 300s installed in all of your rooms with the Modbus wiring, the power wiring, and anything wired up to the relays. So everything, all the hardware is deployed. And we call this the two-person technique. One person is typically at the controller. In your instance, that's going to be in your mechanical room, wherever that is. And the other person will be the roamer, or the person going around to each one of the gas detectors to help with the commissioning. So as the MVR-SC walks through the floor list, it will see these individual gas detectors that still have to be commissioned. So what's going to happen is the guy at the controller is going to click on this. There's going to be another screen that comes up that lists the floor, the room, and if all of that lines up with your Modbus ID, the only thing that needs to happen is the person in the room will use a magnetic wand to ping the MVR 300 in the room, and the controller will recognize that, and the person at the controller will do the commission device, and it will all be done for you. So each one of those devices, and then that person in the rooms goes to the next one on the list, and the same thing is done at the controller. You go to the next one that needs to be commissioned, you pull that one up, you make sure that the floor and the device ID are correct, and again, that comes in from that CSV file, and you do a wand ping in the room and a commission device at the controller. So that's the two-person way to do it, and you walk through each one of those rooms, and essentially the controller itself does the commissioning for you. Now, there's also a one-person technique, and it gets through the same thing, only the hardware is not commissioned yet. You still have to complete the CSV file. You still have to upload that to the controller, but what you're going to do, and this is a reason why that auxiliary Modbus port is in the controller, because you can connect your MVR 300 to that Modbus port in the controller, and it should still be able to walk through that.
Is there a preference over the one-person technique, or the two-person technique over the one-person technique? Seems like the two-person would be a little more effective or a little more efficient.
Yeah, it's a little bit more efficient. It does require two people and maybe a two-way, so they can talk to each other. Because the guy at the controller's got to pull up his side of it, and then the guy in the room's got to ping the gas detector with the magnetic wand. But after that, the system does everything else for you. You're just pressing buttons at that point. I personally think the two-person is a little bit more efficient, but the other way to think about this, though, Rudy, is you can commission all these before you're even ready to install. So if scheduling issues are a problem and you're not ready to install yet, but you can go ahead and assign all the Modbus, it may be worth it to do it ahead of time. And then the one person kind of comes into play. So either way, but I think the two-person is a little bit more efficient.
Okay.
Any other questions? I must have done an outstanding job.
You have.
Yeah. Yeah, I mean, if there's nothing right now, you know, feel free to reach back out. You know, Rudy knows how to get me. If I can't answer questions, I've got people that are a whole bunch smarter than I am here that can help me out. So, yeah, and like I said, if we need to get back together, I'm certainly willing to do that. You know, I think, you know, we're kind of up front here a little bit. When we start getting into the heavy lifting, you know, we may want to revisit some stuff. Rudy, anything on your side?
Not that would be appropriate. I do have some other questions that have come up, but it's more just about the, you know, the technical questions that I maybe ought to get together with you sometime and ask. But no, I think you've covered everything that that we needed to, you know, take the first step here very well. So
Yeah. And again, like I said, if we need to get back together, I've got no problem with that. Okay.
Okay, great. Well, thank you very much, Ken. I appreciate your time and
You're very welcome.
Yes,
I wish everybody luck with the project. We were certainly interested.
Okay.
All right, guys. Thank you very much.
see everybody later. Take care.